Hi there, General Math students. In this video we're going to look at the cosine rule. So the heading has cosine rule, sine rule and area, but this video is all about cosine rule. Now down here we have a triangle, and actually you'll notice that we're moving into non-right angle triangles. Or it says not right angle, but we're looking at non-right angle triangles here. Cosine rule works for right angle triangles too, but it also works for right angle triangles. Now the cosine rule, we've got it here and here. Same rule, looks different, just been rearranged. This is the way we use it when we're finding a side length, but if we're finding an angle, then we'd use this one, and we'll use both in this video. Now, over here we've got this triangle, the non-right angle triangle with a bunch of labels. So the way it works is we've got angle capital A. That means that angle in there, and its opposite side length little a, right? And angle B is opposite side length lowercase b, and angle capital C is opposite the little c. So we're going to label the triangle by labeling the angles with the capitals, and opposite to each of those capitals, the side lengths will have the lowercase, and that's just going to help us to get started with the cosine rule. At first it looks like a really random type equation, but it's actually got a pattern to it, and by using this format for labeling a triangle, we can start we can start out using the cosine rule, but after a while most students will stop using this format once they get used to using the cosine rule. So let's have a go at this example. This one here. Okay, we've got these three triangles. So I've just cut and pasted the rule for each that we're going to use for each of these, just to help with this video. These don't appear on your page, but you might want to write them down or just have it nearby. It's on your information sheet, the cosine rule. So let's try this triangle here. We want to find side length x. So we're going to start by labeling the triangle with A, and then that'll be lowercase a there. So that's angle A. So that's going to be angle capital A, that's 78 degrees here, is going to be that capital A there. And side length little a is going to be over here, right? So that is going to be x squared equals all this other stuff, but at the end we're going to have cosine of 78 degrees. So let's fill in the rest as we go, and we'll use a bit of color just to help us color code here. So we're going to go clockwise. It doesn't really matter, but we'll go clockwise around this way. So we've got angle B and side length B. See how they're opposite to one another? He just disappeared. I'll put him back. And so that means that side length little b, see how that is 5.4 centimeters? So I'll put that into the equation. That goes where this one is. And he'll come again later over here as well. I'll just wait and make sure I've got enough room to put that before I keep writing any more. And then we'll go green for little c, A, B and C. So see how we've gone A, B, C, and side length little c over here. So see, we've labelled the triangle A, B, C with the angles, and then the side length as well. So side length little c is 3.6. So we put a 3.6 in there, but of course those squares are part of the equation, so they're both squared. Then minus 2 times b, which was 5.4, and times c, which is 3.6. I might just be able to squeeze them in. Okay, so I hope that explanation was clear enough. You will get a handle on this as we go along, and I might do the next one just a little bit differently using the same labels, but for now let's finish this one off. So we're going to I'll switch to pure black here. I want x, right? Right now x is not on its own. We've got this squared, so that needs to go over the other side and do the opposite of square, which of course the opposite of square is a square root. So we're going to square root all that stuff. Righto, so let's put that into the calculator. So I'll see if I can remember that as we go. Let's get a square root. So we've got square root of 5.4 squared plus 3.6 squared That's a lot to type in, but you'll get used to it and you'll get quick with this. So we're looking here for 5.83. We'll just say 5.8. We'll go to one decimal place this time. So x is 5.8 centimeters, which seems reasonable. It's always good to think, does 5.8 fit with this diagram? Yeah, it looks like the longest side here. Looks a bit longer than B, so 5.8 seems reasonable. Okay, so no color coding here. I'll just go really quick with this one. You might even want to pause the video and have a go at it on your own first, but I'll have a go at it in just a moment. Okay, so here. Now, we always start by labeling the angle we know with the A. Then we're just going to go around here clockwise, A, B, C, and then lowercase a over here. Little b there, little c here. So in this case, little a is again x. See how that works nicely? So we have our x on its own, or almost. We just got to take the square over afterwards. And you'll end up doing that later. You'll just write straight away x equals the square root of all the different numbers. You'll get really quick with these. But for now, b is 4.6 and c is 2.9. We have to square both of those, but these ones we don't. I'm just encroaching on the next example a bit, but I'll fix that up later. Okay, and so that means x equals the square root of all that stuff. So really, after a while, you just remember you're going to square root anyway, and you just go straight to this line every time. You'll start to see the pattern in this, and you'll get really confident with this rule. Okay, so let's put this one into the calculator. I'll just let you have another look, and I'll have another look too and see if I can remember. Okay, so 4.6 squared. Cosine 118. That was right, wasn't it? Yep. So this time we're getting 6.5 if we go to one decimal place. .5 meters. Okay, so got to make a little bit of room for this last one here. So just bear with me. Just try and shrink him up a bit. See if I can shrink this guy too. Don't want to do what they're told. Oops. I might even just rub that out, guys, and get that out of the way for you. Okay, so this one involves finding an unknown angle, right? So we're going to use this form of the equation instead, but we label the triangle in the same way. This is our unknown angle, so that's the one we're trying to find. We'll call that A. We'll go B, C, around that way. And same with the lowercase ones. Okay, so cosine of A. Now this time, cosine of theta. A is actually theta in this case. That's the unknown angle. And B is 7.2. C is 8.1. And A is 10.3 over 2 times B and C. So you'll start to see a pattern with this one when you practice it as well. So this time we want theta on its own. So we need this pesky cos to go over the other side. What does cos do on the other side? The opposite of cos is inverse cosine. So we take an inverse cosine of all that stuff there. So I'll show you a good way to put this into the calculator, because there's a bit to type in. Okay, so we'll get our inverse cosine first, and then I'll go control divide, and then I can just put the two lines in. I've already forgotten the numbers: 7.2, 8.1 and 10.3. Oops. Sorry about that, guys, just pushed the wrong button, bear with me. Okay, that looks like what we want to have typed in. I'll let you have a look at that. And I'll enter this, and we're getting our angle there. Now, what do we need to do with angles? You might remember we need to DMS them, or make them into degrees, minutes, seconds. So we'll send that straight to that. 78 degrees, 46 minutes, 3.7 seconds. So that'll round to 78 degrees, 46 minutes. So that's how we'll express our answer. So go ahead, practice these ones, and after a while you'll probably find you don't need to label the triangle anymore, but it's a good way to start out.